Problem number 12 says, the photodissociation of water, H2O plus HV reacts to form H2 plus 1/2 O2, has been suggested as a source of hydrogen. The change in enthalpy for the reaction is 285.8 kilojoules per mole of water decomposed. Calculate the maximum wavelength in nanometers that would provide the necessary energy for the photodissociation of one molecule of water. So the first thing you should notice about this problem is that they give you an energy and they want the wavelength. So we're going to be using the equation, and my apologies. Energy equals hc over wavelength. Or since they want the wavelength, we can convert this to wavelength equals hc over energy. And you remember that h is Planck's constant, and that has units of joules times seconds. Okay, just keep that in mind. So the reaction that the energy that they gave you is 285.8 kilojoules per mole. Okay? But this quantity is going to be more useful to you in joules, because when you put it in this equation, you're going to have to put it in terms of joules. So the first thing we're going to do is convert this to joules by just remembering that there's 1,000 joules in a kilojoule. Okay? And you see what's going to happen? These kilojoules are going to cancel out. So right now we're up to joules per mole. However, we want to calculate the wavelength for the energy to dissociate one molecule of water. So we have to convert this moles to molecules. So just remember that in every 1 mole there are 6.022 times 10 to the 23rd, or Avogadro's number, molecules. Okay, so the moles now cancel out. And you can see you're going to be left with joules per molecule. Okay, so this number actually works out to 4.74 times 10 to the negative 19 joules per molecule. Okay, so now we have the energy. Now all we need to do is plug these into the equation. So energy equals, Planck's constant is 6.626 times 10 to the negative 34 joules times seconds, times the speed of light is 3 times 10 to the 8 meters per second. And this is all over 4.74 times 10 to the negative 19 joules. Right? So the joules are going to cancel out. The seconds are going to cancel out. And you're going to be left with a quantity in meters. And that quantity is going to be 188 rather, times 10 to the negative 7 meters. Okay? But they wanted it in nanometers, so the conversion for that is just times 10 to the 9 nanometers per 1 meter. And you're going to be left with 418.8 nanometers. So you look at answer choice 1, it says 419 nanometers. That's close enough. So yeah, there's your answer.